All right, so this one's going to be very similar to what we were doing Friday and what we did on the homework. We've got 2x cubed plus 5x squared minus 11x minus 14. It is just a little bit different than what you saw in the homework. Anyone pick up on the difference? Okay, we'll see if we see the difference after we do the first step or two here. We're going to look at that shortcut as far as we're not going to have to do the actual list part. We are still going to do the P and the Q, though. So P and Q. Isaiah, what's the P? 14 or negative 14, doesn't matter which you put, because again, we have that plus or minus we're going to use. So again, the P is the constant, the last number. We do still need to list the factors. So 1 and 14, 2 and 7. And then Kelton, what's the Q? 2. So that's the leading coefficient. And so the factors of Q are going to be 1 and 2. That's all I'm going to have you put until we jump into our synthetic. But just so I can show you why, let me put the list here just to remind you. So you don't have to write this part. I would put all of these divided by 1. So I'd put plus or minus 1, plus or minus 14, plus or minus 2, plus or minus 7. And then I divide all these by 2. So plus or minus 1/2, plus or minus 14 divided by 2 is 7. It's in my list. 2 divided by 2 is 1, in my list. 7 over 2, not in my list. So I put 7 over 2. Think about what we're using this list for. We're using our list to do synthetic. The 2 new numbers I have here that aren't in the P list are 1/2 and 7/2. Do you want to do synthetic with fractions? I don't either. So really, this list isn't going to be something that I'm going to do synthetic with, that I'm not going to pick the numbers that are just the P factors. So we're not going to use this list for our synthetic unless they're P factors. So in front of the P, I'm just going to put plus or minus just to remind myself I want to use those numbers, but I do want to use the positive and the negatives. And we're going to pick the smallest factor still. Well, every time the smallest factor for any number is always what? 1. We're always going to try 1 and then negative 1. Unless I tell you otherwise. There's going to be 1 in our notes that I say, oh, we shouldn't try 1 because it's going to happen later on. There's going to be 1 in the homework that I say, start with this factor instead. Otherwise, we're always going to start with 1. In this case, we're going to start with 1. And I know 1 works if I get a remainder of 0. All right, synthetic, here we go. Just make sure you're not going too fast. You don't make one of those silly mistakes. You saw me do it when we went over homework. Does it look like it's going to work? Nope. I like to cross it off. If you want to erase, that's fine. What should I try next? Negative 1. Those are always going to be your first 2 choices unless I've told you to try other numbers otherwise. And again, you should find them in the first 4 as long as you're working systematically. It works. Whoops, I got ahead of myself. Sometimes that happens. I get so excited. Getting sloppy today. I like to put that x equals just so I remember that I am getting an x equals when I find that. So x equals 1, x equals negative 1. So this is what worked. X equals negative 1. So that means when I go to my next step, I'm going to have a binomial. The binomial is going to be x plus 1. This part makes up the trinomial. The trinomial is going to be 2x squared plus 3x minus 14. Now do you see how this is just a little bit different than the other ones? It's a guess and check factoring. We had a number with that leading term. So our factoring is just a little bit harder. Well, I think it still factors. If we're not good with guess and check, or it doesn't guess and check, guess what we'll have to use? Quadratic formula. I keep saying it. Do you think we might have to use it today? I bet we might, but I don't think we have to here. Anyone see it yet? When you think you see it, let us know. That order, 7 and 2. Opposite signs, so we want this 7 to be positive or negative, Jordan. Let's see if Jordan's right. If he's back on his game here. -4, +7. Yeah, -4, +7 does give us a +3. All right, we still have to solve. So we're going to get x equals -1. Didn't lose track of that. Here, I like to do that middle step, x equals -7. Sorry, 2x equals -7. So x equals -7 halves. Oh, that was in that big list that I wrote out. X equals 2. All those numbers are in my list. So again, hopefully you're not finding this super hard, but it is a little tedious. It is a little challenging in the sense that, oh, you got to be a little persistent. You got to stick with it until you find that one that works.
So you can always go back, once you solve for x, you can always go back to your p's and make sure that those answers are there.
Yep. The only ones, if we're not doing the whole list, if you have a fraction, it won't be in your p-values. But if you have...
still be able to figure it out through p and q. You see
Yep.
a 7 and a 2, so you should figure it
Yep.
out.
Mm-hmm.
And then you know if you're right or not.
Yep, exactly. Well, there you go. Yeah, so he said he was going to ask the exact same thing. So if I got down to an answer and I got, oh, x was 6, if I don't see 6 anywhere over here, I know I did something wrong. But yeah, that's a great way to double check. And that's a good habit to be in because if you're on that quiz or test and you're like, whoa, I did something wrong, that's good. Some of you are in good habits of doing that. And some of you just, hey, you circle your answer, you move on. Which, if you're on a time crunch, that's one thing. But if you turn your test in, there's 20 minutes left, take a second, go back and double check. Anything else on this one? Okay, let's look at this one. X to the 4th plus x cubed minus 7x squared minus 13x minus 6. I think this one's a little different. Anyone see how this one's different? 5 terms. We're going to start it the same way, though. We'll see how it's different after we get through it a little bit. We're still going to be able to start the same way, doing our P and our Q. Again, we won't worry about the actual list. So we've got x to the 4th plus x to the 3rd minus 7x squared minus 13x minus 6. Whew. We're not going to have anything that's really harder. We're just going to have to be persistent. All right, Xavier, how about the P? Good. Chandler, how about the Q?
1.
Good. We're going to have factors of each. So 6, start 1 goes in there 6 times. 2 goes in there 3 times. Those are all my factors. 1 is just 1. Again, I'm not going to do the list. I'm just going to remember that those p values, I want to use the positive and negative values. All right, so I'm going to start with 1. A little carried away there. Well, am I missing any terms? No. We saw from the homework, we always want to be on the lookout for that. 1, 1, -7, -13, -6. Well, this looks fun. 1, 1, 2, 2, -5, -5. Of course, the first one didn't even work out. What would I try next? Okay. 1, 1, -7, -13, -6, 1, -1, 0, 0, -7, 7, oops, -6, 6, 0. Yes, success. Wow. You guys should be yelling at me. Make sure that phone's off. Not being in good habits, putting the x equals up there. All right, I don't want to lose track of that. So I'm going to say x plus 1. Now, what do you think this is going to start with? X to the... Good job. So x to the third. I don't know. I'm going to put 0x squared minus 7x minus 6. Four terms. So usually when we got to this point, we're like, oh, okay, I'm going to factor that. Well, let's see what happens if I wrote it, if I didn't put that 0 in there. If I just wrote it x cubed minus 7x minus 6. It's a trinomial. But it's x to the third. Well, the only way I can factor x to the third, I need those four terms. Well, it's kind of missing that one. Or if it's a sum or difference of cubes, if it's that pattern. Well, it's not that pattern. There's three terms. Well, I'm stuck. This means it doesn't factor. Chandler.
If you did have 4 of them, did you factor by grouping at all?
So that's a good question. Let's say this was like an 8. If this groups, by all means, group it. That would be a great idea. So that would be a good thing to try. If you get down to 4 terms and you can pull out a GCF and the parentheses match, do it. But we're stuck because we don't technically have 4 terms. We don't have 2 terms. So that's the only way we can factor if it has x cubes. It has to have 4 terms or 2 terms. We're stuck because technically it has 3. Well, how else have we been solving when it has 3 terms? Well, that's if it has 2. You said smiley face. We did it on the first problem today. You did it on your homework Friday. Look at the first problem we just did. The answer's not up on the board. Look at the first problem. Chandler's looking at his first problem. What? But before we factored, what did we do, Bree?
Oh, synthetic.
Synthetic. Didn't we just do synthetic? Isn't that what we've just done on all the problems on Friday? If we don't have a way to factor, we have to do synthetic. We have to go to that list and we have to see what works. So, oh my gosh, I'm telling you, we have to go back to the list and we have to do synthetic again and we have to try and see and figure out what works. Well, here's some good news. Maybe, maybe not. I mean, we're still guessing and checking. But 1 didn't work up here. So I'm telling you, 1 didn't work for this big thing. 1's still not going to work. It's kind of like, maybe this is too much. Some of you will get this, some of you won't, and that's okay. But it's kind of like if I have 5x squared plus, or x squared plus 5x plus 6. No. Let me go back to, what was that? When we had 2x squared plus 3x minus 14, if I tried to do guess and check, and I tried to put 2 in this spot, was there a GCF up here? Is there a GCF in this trinomial? So should there be a GCF in this binomial? No. That's why this didn't factor. So if I know 1 didn't work, 1 wasn't an answer for the big thing, 1's not going to be an answer here. So I'm not going to try 1 again. -1 was an answer. It could be an answer again. So, good news, I don't have to make another list. I can go back up and use the same list. So use the same list and try whatever just worked on this polynomial. So I'm going to use x equals, I'm going to remember this time, -1, because that's the last one that worked. And I'm using it on this polynomial. So I'm using 1, 0, -7, -6. I'll bring down my 1, -1, -1, 1, -6, 6, 0. It worked again. So what that means is -1 was a solution to this thing 2 times. That means there was this binomial, and then I have a binomial again, so I bring down this. I bring this one over, another x plus 1. And then what's here? X squared minus x minus 6. So that x minus 1 was a solution 2 times. We're down to this point. Do you think I can factor this? Yeah, I think I can factor that. All right, so I'm going to keep x plus 1. Could I write it as x plus 1 squared if I wanted?
Yeah.
Yeah, if you wanted to save room. I'll write it twice. X plus 2x minus 3. So you can write x minus 1, x minus 1, or you can just write it once. You got -2, and you got +3. Yeah. Yeah. Are you okay?
Yeah, I just go to the bathroom.
Okay, it just came on suddenly. I was nervous for you. How many answers is that? 4, because I had that -1 2 times. How many answers did I have on the last one? How many answers do you remember did you have on most of your homework problems? Now, this is going to be a stretch. When we had parabolas, how many answers did you usually have? 2. Parabolas, what does the equation look like? It's a stretch, I know. How can you remember that far back? Standard form for a parabola. Y equals ax squared plus bx plus c. So ax squared. This is x to the 4th. The ones we were solving were x to the 3rd. What do you think tells us how many answers we're going to have? The exponent. Specifically the largest, which we call not the a, the degree. The degree tells us how many answers we're going to have. Now, there is kind of an exception. We don't have to have that many. We can have at most that many. So we can have 4 or fewer, because technically this is kind of like having just one answer. So I really might call this having 3, because it's 1, 2, 3. But this you could count as 1, 2, 3, 4. But at most I would have 4. There's no way I could have 5 answers for a problem like this. There's no way on a problem like this I could have 6 answers. The degree tells you at most how many answers you have. Let's put that in our notes. the degree. We'll remind ourselves that's the highest exponent. Tells you at most how many solutions there are. Since we're doing this writing part, we'll get to this a little bit later, but well, maybe let's just do it. We'll do it out of order. We'll come back and we'll do another one of these powers of 4. But where, if I'm thinking about graphing, where is the solution on the graph? Think about our parabolas, because that's what we're used to. Where are the solutions? The what? Where it crosses the x-axis. So the solutions, and that holds true for any type of function. It doesn't not just a parabola, even these higher powers. The solutions are where, we'll just put where the graph crosses the x-axis. So I want to come back and do another one of these power of 4s. I want to come back and do this one. But let's do this one first. So you're going to be given a graph. It's up to you whether you want to try and sketch that or not. So I will tell you, if I kind of look at this and people up front can see it better, this looks like it crosses here at x. Well, that's not an x. That looks like it crosses at x equals 1. This looks like it crosses at x equals 2. And this looks like it's at x equals -1 if you want to try and sketch it. If I were sketching it, I'd make a little coordinate plane. I'd put dots at -1, 1, and 2, and then I'd try and throw a curve up there. And then you're going to write down that function. I put y, you can also put f of x, that's interchangeable. You're going to have a couple of these on your homework today. For these problems, you're not going to need to do the P, the Q, and the list. There's another way we're going to be able to start our synthetic. Because we're going to be able to look at the graph and decide where the solutions are. Remember, 0 is just another name for a solution. Well, I find one of those places where it starts. You can pick whichever one you want. Now, on the book, or the graphs in the book, it doesn't cross nicely, shall I say, at every place. Some of them might be fractions or decimals. So I want to find some place where it crosses nicely. Well, this one, all 3 places are nicely. So I'm just going to pick one of those places. Eva, do you want to use -1, 1, or 2? So she picks 1. I like 1. That's a nice number to work with. So I'm going to take that as my answer. So I'm going to say x equals 1. And I'm going to use that to do my synthetic. And the way that I'm verifying is then when I do 1, I should get a remainder of 0, but I should be able to factor and get all my other answers. So let's see. No missing terms. 1, 1, negative 1, negative 1, negative 2, negative 2, 0. So I know that's right. That makes sense. It crossed at 1. That's verified. But I don't want to have to go back and do synthetic for the other two. I want to just say, okay, I know x minus 1. Now I'm going to have x squared minus 1x minus 2. I want to be able to factor this and make sure I get these other two values. So I'm going to have x minus 1. I'm going to factor this. Signs are different. So negative 2, positive 1. So my answers are 1, 2, negative 1. That's the 3 places that it crossed. I verified it. So when you get, I think there's 2 problems on your homework that are graphs. Do you have to do the P and the Q? No. You're just going to jump in with one of the values from the graph. The values where it crosses the x-axis. Chandler.
And say one of your solutions is a fraction.
Mm-hmm.
When you factor, we go find out if that's one of your solutions.
Yep. And so let's say this was a 3. And so you would have had 2/3. And so you'd see, oh, well, that's in between 0 and 1. And so that's why it's in between. All right, we're going to end with this lovely one. I'm saying that, so it's probably not really lovely. That was laced with a lot of sarcasm. So one of those degree of 4s. So we're going to use f of x is x to the 4th minus 2x cubed minus 9x squared plus 10x minus 24. And this is one where I've said a hint is not to use 1, negative 1, 2, or negative 2 because they are not zeros. So I do not want to use 1, 2, 1, negative 1, 2, or negative 2. I'm going to start with whatever the next factor is. But I'm going to have to do my P and my Q first to figure that out. Someone let Price back in. Thanks, Joe. So let's see. P, 24. Q, 1. 24. 1 goes in there 24 times. 2 goes in there 12. 3 goes in there 8. Lots of factors. 4, 6. That takes care of all of them. 1 is just 1. I'm going to put that plus or minus in front of P. If you forget the plus or minus in front of P, that's not a big deal. That's more of a reminder to yourself. So again, this hint is for you. That's to tell you, don't do synthetic for 1. Don't do for synthetic for 2. So what's the next biggest number? All right, so we're going to use 3. Let's see, 4, 3, 2, 1, 0. No missing terms. Let's see if I was nice and I gave us the first one that worked. Does it work? Nope. Think negative 3 is going to work? Let's see if Price is right. I think he might be.
Did everybody put the x3 and x equals negative? I don't think everybody did.
Ah, gosh, bad habits today. I don't know what happened over the weekend. It's a subtle reminder, Mrs. Clippinger.
That was just directed in general, not to me.
Was it? It should have been. It should have been directed
I'm
just
sorry
at me.
you took it that way. That was not my intention.
It should have been. All right, so that does work. Price was right. So x does equal negative 3. So again, especially when these get longer, we don't want to lose that factor. That's what I see happen a lot. So I'm going to put x plus 3. This new polynomial, since it was x to the 4th, this is going to be x cubed minus 5x squared plus 6x minus 8. So now we do have 4 terms. So this would be what Chandler was asking. Should you take a second and try and group it? Yes. Unfortunately, this doesn't group. So we're going to go back. I don't have to redo my list. This list still applies. 1's not going to work. It didn't work before. 2's not going to work. It didn't work before. 3, it's not going to work. -3 might work again. So I'm going to try it. We saw how that -1 worked twice. Thank you. Gosh. 1, -3, -8. 20. Oh, this is not going to work. All right. So then I look back at that list. It's the next thing on that list. Hope this works. It's getting kind of tedious. But we got to show some persistence. Oh, it's going to work. So I've got this new factor, x minus 4. I got to bring this one over. Don't lose that. X plus 3. Then I've got x squared minus x plus 2. Then guess what? It doesn't factor. So that means no! We're not going to try and squeeze this in, though, because Bella's going to ring. We'll finish it on Wednesday. Remind me. We're going to do the quadratic formula for that part, but we are going to have answers of 4 and -3. This homework is going to be due on Thursday. We'll take a little bit of notes on Wednesday, and then you will have a good chunk of time to work. Make sure you write this because I didn't put this on the board. On 14, it's like that one we just did. You want to try 3 first. Don't try 1 and 2. Number 8, you are just listing. So you do have to do PQ in the list. Your only thing that is due on Wednesday is your reflection. Make sure you have that Google form filled out. Once you have that, you can go.